All right. Good night, everybody. Good evening. Welcome back to vBrownBag. Tonight, we are going to continue our NSX-T series. This session will be about NSX-T design, specifically things you would need to know to prep for the VCAP-NV. So this is a great one. A lot of good stuff to get out of this one. Before we get started, though, a couple housekeeping notes. This is being recorded live. If you joined us live, welcome. You should know that you can find us over on YouTube and all of our back episodes. If you missed any episodes in this series, check them out there. If you're watching this on YouTube, then hey, thanks for watching. Did you know that we do this every week, almost at least, on Wednesday evening, 7:30 p.m. Central? And we do this in other times and sometimes even other languages. So if you're in a different time zone, different region, speak a different language, check out our other shows here on the right. Just a reminder, if you are watching live tonight, please use the Q&A in Zoom, or you can just tweet at us and use the hashtag vBrownBag with any questions you may have, comments, snide remarks, whatever, inside jokes, send them our way. Yeah, tonight we are pleased to welcome back Britton Johnson, VCIX-NV. I didn't mess that up this time, Britton.
Nice job.
That's his Twitter handle. I'm Ken Nalbone. You got any questions? If you want to join vBrownBag, you can tweet at me directly. My DMs are open. Would love to hear your ideas for more enablement sessions for the community. But without further ado, I am going to turn it over to you, Britton. So let me stop my share and pass you the ball.
All right, let me get going here. There we go. Okay. Good times. Let me make sure I got everything I need. Good. And good. All right. Cool.
All right.
And good. All right. I think the whiteboard is working. Should be good. All right. Welcome, everybody, to number 3 in our 4-part series of NSX for the summer of 2021. This would be a little bit different than the stuff I've done before because this is going to be really more kind of theory and practice and kind of just the logistical side of what it takes to do NSX. Reason I wanted to do an NSX-T design session for vBrownBag this year. So earlier this year, I had to renew all my certs on everything and reclaim my at VCIX-NV status and renew that because I originally got it for NSX for vSphere. And so I retested and got the VCAP-NV for T, NSX-T, and then I started down the track of what it would take to renew my VCIX-NV. I thought I would have to take both the VCAP-NV and the VCAP-NV design and the VCAP-NV deploy. As of at least when I did it, I don't know if it still may not be out. There was not a VCAP deploy exam. So just by passing the VCAP-NV design exam, it renewed my VCIX-NV.
So when was that, Britton? Because people might be watching this long before we record it.
So that was spring of 2021, so just a few months ago.
Okay.
So you'll check the the VMware exams list to see what's currently out there for everything. But in the future, in order to obtain the cert level VCIX or the VMware Certified Implementation Expert, which is the one just below the VCDX, you have to have both the VCAP-NV design and deploy exams typically to get that cert. But because I was a prior, they grandfathered me in with one. So I'll take it though. So anyways, as I was looking around trying to figure out how does somebody prepare for the new VCAP-NV design exam, I'm like, well, you can take the official class. So I did that. But then also, when just looking around, there was not a lot of material in terms of study material for like how to even prepare for the exam. Because I like to know what's on the exam and I want to understand that process. So I thought, well, let me just work through this and then I'll make some stuff. And so here we are. That was a really long intro. I'm sorry. All right.
All good, man. It's good to set the stage.
Yeah. So again, if you have watched any of this stuff, you don't know who I am by now. This is who I am. I updated my picture to my Twitter picture. So this is me at the zoo in Madison, Wisconsin, explaining to Bucky Badger how to virtualize his network. And he was not listening very well, but, I'm a staff solutions engineer for the virtual cloud network team in VMware. And, been doing this for a little over 2 years now for VMware. It's been great. That's me. So again, hopefully folks watching this know who I am by now because they've hopefully seen all the other ones. Agenda for today. So we've done the first two, general update and then the advanced threat protection suite. So this one is the NSX-T Design. Yes, I did, as Chris Williams aptly noted during tweeting the promotion for this episode tonight, this is a ridiculously long title. But realistically, these are the things that are contained in the exam. Then so it's stuff that, if you're after the VCAP-NV design, this is stuff that you'll need to look at. So, and then again, we're going to wrap this thing up, party on the 25th with the NSX-T migration V to T. Try to cover that in as much detail as possible and what that looks like and what your options are. And we'll, have a good time closing out the series with that one. All right. Learning resources. So as I always start with these things, this is kind of the couple of quick go-to things that I hope people can either, steal these links or go to Google and search later on. So still, check back to the 2020 vBrownBag series for all the core content on NSX-T. Still very much valid. I updated this to a bit.ly link, so if people are looking for it, it's a quick kind of, hopefully that works. And then really the NSX design Bible, as it were, is the reference design guide. So if you are doing anything with NSX-T and you need to understand how to do something, or you need to understand a scenario, or you need to figure out a best practice principle, go to the NSX Tech Zone for a lot of different resources, but ultimately go for whatever is the current iteration and version of the design, the official design guide. This thing is updated fairly regularly, and it's kind of your one-stop shop of where to go for all things NSX-T knowledge-wise. So definitely go grab that and keep it bookmarked so you can check back at a regular basis. Of course, the VMware Education official design course. So this is, again, it's a very good course. So if you've taken, let me ask you a question. You've taken the official VMware Education courses, yes?
Yes, several. Not this specific one, but several.
So typically they contain lots and lots of lab time, right?
Oh yeah, absolutely. At least a quarter of the time probably is lab time.
So the interesting thing about this course is there is not a lot of hands-on product lab time because it's not really about the practical aspect of deploying and clicking things and doing deployments and understanding where stuff is in the UI and all that kind of stuff. So the lab portion of this class is basically walking through scenarios of figuring out design questions and stuff. And teaser for the end of this episode, I'm going to walk Ken through kind of what that looks like in a lab type of a thing. So
I'm going to ask people not to judge me on that one, by the way.
it'll be fine. Trust me. There's no wrong answers. So
I think when you take an exam, there usually are, though.
That's true. So yes, I may have just lied there, but for the purposes of this presentation today, there are no wrong answers. I'll say that. All right. Additional learning resources. If you're after the advanced design VCAP-NV exam, this is the exam number. So that is, super key to know that. And then the other thing to pay attention to is, go download for any exam you're taking, the exam guide blueprint. This is a key piece of information, and part of every exam prep should tell you to go download the blueprint. The blueprint in this case is to my perspective was lacking a little bit of information, probably by design, no pun intended, because they want you to go figure a lot of this stuff out and prepare for it, in a very kind of a one-off way. So this particular design exam design blueprint PDF, as you go download it, this is publicly accessible document, so no secrets here. It's a 3-page PDF, and so all of the exam prep guides info is really contained on page 2, and it pretty much consists of everything in section 3 is what you need to study. So that's sort of the big deal with the exam, with this particular exam especially. Pay close attention to what is not, I emphasize not, covered in the exam, because if you go into the exam and you spent a whole bunch of time learning, install configuring and setup and troubleshooting and repairing and, any of the, architecture discussion stuff, none of that's on the exam. And so just as you're going through it, make sure that you're covering the bases of, the stuff that's on this list, and walk through a lot of these kinds of designy type scenario things. So that's my first little bit of wisdom. It might be kind of a duh, but I felt like it had to be said. So
honestly, until you called it out, I didn't notice that it just said on every other line, this is not on the exam.
Exactly. Yeah. So, all right. So I'm going to spend a lot of time talking. There's not a lot of, I actually have a total of 21 slides. So I don't have a whole lot of slides. I usually have like 50 or 60. So there's going to be kind of a, small amount of slides, a lot of depth on each one of them. So that's sort of this is almost, like I said, it's a whole different type of presentation. So it's really just more about, how we work through this process and what it looks like to design something. And I really feel like a lot of this material should be universal to really any design process, not just an NSX-T design process, but really any design, any IT highly advanced system that you're deploying or working with. This is a process that really could be universally used. At least a good design process should be, repeatable in that respect. And so we'll talk about that. All right. So at a high level, the NSX-T design process, as we would espouse it begins with number one, a framework. What is a framework? A framework has several different features. It's a toolkit that can be used to, for delivery and assessment of a broad range of architectures. So like I said, not even just limited to just NSX or even vSAN or some other VMware product. This is something that goes across the board for anything that you're trying to do. It contains a structure, for content or a process that can be used as a tool to represent thoughts and ensure consistency and completeness. A framework typically consists of, these primary 3 things. So a methodology, standards, and tools. And when we talk about tools, often they're supporting tools. So they're just, bits of a process that help get things going in the right direction. A design methodology also describes what we would call an iterative or high-level process that is used to create the design. And so that's, it's something that is not necessarily static in nature. So because it's iterative, it has to change and flow as you work through the process. Standards also, as they are used in part of the framework, get developed in the field, and kind of where the rubber meets the road. They provide, guidelines, not necessarily rigid rules. Standards include configurations and processes. The standards are sometimes common practices, and they're used to avoid problems and get results. But kind of as with most things, you have to balance best practices and standards with an organization's objectives. So the thing that I kind of took away from this as I was working through this material again is, the design process in general usually involves a lot of compromise because there's going to be things, as we'll get through this, where you've got a hard locked process that you're going through for, like, say, you have to use a certain type of hardware because that's what you have available, or that's what has already been purchased, or you've got a certain number of network switch ports that you have available to your deployment, or there's certain things, there's certain constraints on the process, and that's going to make it, you have to go one way or the other. It's it's not like a choose your own adventure book, back when we were kids. Except probably less fun than a choose your own adventure book.
Well, you got me all excited. And
yeah. So that's thing one. Thing two is principles. Guiding principles are. I skipped tools. So the last piece on this before I head into the principles. So design tools also are contain supporting artifacts used to execute the methodology. So the tools there's a lot of this kind of thought process in here too, where it's sort of a circular logic as you go through this, where the framework builds the methodology, which it contains standards and tools, and the tools also build, they support the framework. And so it's a lot of this kind of circular logic rolls through this thing, where this thing leads to that, which leads to this thing and goes back again. Probably the main and most important piece of tools and supporting tools of that is setting up a defined vocabulary of terms unique to the framework. So that's where, as you're rolling through an NSX design process, if you're starting to build out, profiles within your NSX environment of, host profiles and, physical NIC profiles, and just all the different components that make up an NSX deployment, you can kind of start to contain the specific vocabulary of the terms unique to what you're trying to do built into the framework as well. So that way, as you're talking about it as a team of people building these things, you can all kind of talk off the same sheet and be on the same page from that aspect. Okay. Principles. Principles are best practices and recommendations for the correct assembly of this architecture. That is, again, where principles go back to the framework. So, whatever the framework says as the process, the principles have to support that as well. Best practices are often used in the absence of other requirements. Again, key thing here, best practices are not static. They evolve as technology evolves, and realistically, there is no single online location for best practice information, except, as much as everybody in IT would like to say, we'll just Google it. You could do that, and then 5 years later, do it again and come up with different answers. I've often heard the best way to test a search engine is to Google what's the best weed whacker, and see what you come up with. But
ads.
Exactly. And so it's one of these things where, like, it's going to change, it's going to iterate. And that's why, customers always seem to be after this thing of best of breed, best practices. They want the best. But, especially in technology and software, whatever's the best now is not the best later. It used to be that the standard requirement for business internet was getting maybe one or two 1.5 megabit T1 lines installed in your business, back in like the late 90s, early 2000s. I remember one of the first places I worked where they had a T1 line. Man, I thought it was the best thing ever because their internet was screaming.
I worked somewhere that had two bonded T1 lines, by the way.
Oh, man.
I can't believe that.
That was awesome. 3 megabytes up. Wow.
Oh, yeah.
I think I could do that on my phone now. So it's just one of those things of, like, all these standards and best practices change. If the best practice of a T1 line for internet in a business never changed, I think the world would look a lot different than it does today. All right. All right. Recommendations. So realistically, so the recommendations piece is just sort of akin to the best practices piece. So, like the recommendations to me, what that speaks to is sort of the working with field experts. So people who are, professional services folks who do design and delivery processes, all day long. The guys who have guys and gals who are in the trenches deploying these things on a daily basis. So, someone other than Ken and myself. So, because those folks always have kind of the bird's eye view as to what's really going on and what is the right solution for most situations, because they're they're just down there doing it. And so, when I take their recommendations higher really than anybody else, because if you're in the field and you're doing it, you've got the most up to date, valuable information, and applying that kind of stuff in the beginning of your design process is invaluable as you get started. All right, design sessions. So design decisions get made during design sessions. That's probably not a revelation to most people listening to this, but this is where we are. Though these decisions get made through interviews or whiteboard sessions, this is stuff that IT people do in and out all day long. So again, not a lot of aha moments here probably, but this is just kind of the stuff that, again, it's on the exam, so we need to cover it. And realistically, to provide a solution that works, we have to involve key stakeholders and subject matter experts, early and often in those design sessions. And there's one note that I pulled out of some of the materials for this, where they say, do not surprise the key stakeholders and subject matter experts. So, and I don't know how many times I've been working on a project for somebody, and then at the last moment they're like, oh yeah, by the way, we found this thing and now we have to do it this way, surprise. And it just changes, everything that you've been working on for months, because now we have to meet this new expectation that could have been found early on, but maybe wasn't. And so, it's that kind of stuff, like, the technical surprise 3 months into a project, it's never fun. And then, ultimately we need to understand and to be able to explain design risks caused by various, constraints and requirements. Designing is this balancing act between, technical best practices, the business's organizational goals, requirements, and constraints. And we're going to talk a lot more about most of these things, especially the requirements and constraints, and the risks and all that stuff, because that's half the exam. It's just working through this thought process. And kind of the last part of the design sessions part of this is we have to perform this, final gap analysis between the design and the organization's goals and requirements. And so you're going to have pieces where, as you get through the design part, you're going to have what the requirements are, what the solution can do, and you're going to have a gap between them. And we've got to be able to fill the gap and make sure that ultimately, the design meets all of the requirements that the business has decided to have. So, it's really just sort of that's kind of probably one of the most critical last piece steps is doing this final gap analysis. All right, I think I may have already covered a lot of this stuff on the trade-offs part. So yes, I did, and I didn't skip ahead. I made presentation mistake number 1, Ken. Note that down.
All good.
I'm not used to click through slides, if you can't tell. All right. Yep. Okay, last piece. Let me just build this out all the way, and then I won't forget anything. So the most important part of this thing is that really, yes, it's the outcome. And a good design involves the organization's key stakeholders and subject matter experts. And the lack of proper team input, is part of, really, as we talk about, constraints and requirements and risks and all this thing. One of the things that I deal with all the time, even today, is, oftentimes you'll start a project, but you won't have all the right people involved at the outset that need to be on board and need to have input in what you're doing. So how do you press forward without all those right people? And as part of this process of, building the team that's going to do this design and do the deployment and kind of understand what all the, the outcomes and the risks and the constraints and the goals and the requirements and all that stuff is, realistically, if you don't have all of the right people on board at the outset, you have to call that out immediately, as a risk to the project, because if you don't have the people, you can't make the design, and you've got an outstanding risk right at the outset. So, be sure that you understand who needs to be involved, and make sure you try to get them all, on board and informed as quickly as possible, because that's what helps you get to a good design. A good design also balances the business goals and requirements with technical considerations and best practices. So again, it's a bit of a give and take. It's this kind of, it's a balancing act. I can't think of a better way to say it at the top of my head at the moment. Compromise. That's what I was going for. And so
we got there. Good job.
I had to give my brain a second to catch up. There's compromise involved in all these things. And it takes, time to kind of work through some of those things and figure out, how the technical considerations and best practices work towards the business goals and requirements. But it's part of the process. And I think for the engineers in the room, myself included, that's probably the hardest part of doing this, is getting, to the balance part and making sure that, all the stakeholders and SMEs understand, that the business goals are important, because, as technical people, sometimes we look at, the business goals and the requirements of things, and we just think, well, that's, like the best practices are the technical thing, the cool, shiny, flashy thing. That's the thing we want. But oftentimes we have to let go of the cool techie stuff, because if it doesn't ultimately, meet a requirement of what the business is trying to do, then you're overcomplicating things for no reason. And so this is why project managers are, especially good project managers, are really important to an organization, because they can help, define the outcomes and define the requirements and help, businesses achieve this balance between, the technical good stuff that is in a lot of products, like NSX-T, and the things that businesses need to function and to gain value out of those investments that they've made. And a good design also has, a documented rationale for its considerations. Ken, I don't know about you, but documentation in general has always been sort of my Achilles heel.
Oh, 100%. It's not the fun thing to do, right? It's like,
right, yeah.
Oh, I know it's important, but I'd rather just learn this cool new thing, or see what happens if I change this config file.
Right. But that's the thing that gets you to these last couple of pieces here, is being simple and repeatable. Because if you don't have a document that shows the rationale and understand the considerations of why you did what you did, then you'll never get to the point of being simple and repeatable. And that's the piece of it that it's really hard for certain brained engineers like myself to get over. It should also include sufficient enough detail to be unambiguous and should not be complex. It should consider the target states of things. And it should be, kind of a constantly evolving document. I will never forget the first time I ran across an organization, worked for an organization, not VMware, worked for another independent company where they had a consulting division that was doing this kind of stuff. They were building, entire design frameworks and processes that met all of these things. And that was basically their business. And one of the senior security folks involved in this, effectively, he had a requirement that any project that they were working on, in order for them to, execute the project, it had to have this document that contained all of these things. So, everything on this page and then some, but it also had to have the extremely specific step-by-step instructions of how to actually go in to execute it. Because from their perspective, when the rubber met the road, they wanted to know that if the engineer who was tasked with deploying it got in a car accident, or use the proverbial term, was hit by a bus, that somebody else could pick up that document and execute on all of this stuff to the same degree that the super smart engineer could. Now, that always spawned off lots of arguments about, well, I'm an engineer, I'm super smart, why do I need to follow this step-by-step document? It kind of made for some heated discussions within the organization, because if you're going to go through and build a step-by-step blueprint design plan, then why do you need the engineer to do the deployment? You could just have anybody do it. But the whole idea of why this was important to them was because it gives them this one set of outcomes that's simple and repeatable. And that's really it. Because if you don't have that, you kind of don't have anything, because you've sort of spent all this work trying to get to this point. And this is the thing that every organization, when they're building stuff out, should be after. They should be after having a balanced, design that meets all the requirements, and it needs to be simple and repeatable. Because if you don't, otherwise you're doing a lot of this adoption of new technology kind of for naught. Because, and this is why a lot of organizations have so much shelfware, where they buy stuff and then never use it. And it's because we just don't have good processes in place to consume these things. And that's, I'll step off my soapbox now, but that's sort of what the way I envisioned that. Have you seen something like that, Ken, in the past?
You mean like that really complex requirement for documentation?
Yeah.
I wish that I had seen it more. Let's put it that way. Because this goes both ways, right? If you're trying to help an organization looking for outside help to modernize whatever that they're doing, and you want to know what's the state of the current environment, and they're like, we don't know, somebody else installed it years ago.
Right.
We don't have anything, that kind of thing. So it helps us out too.
Yeah. All right. Diving a little deeper into the framework. So that was the process. This is just specifically going into the framework part of it. So when we're looking through this process, we're going to use a framework that does all of these 5 steps. It identifies the stakeholders, extracts the relevant business drivers and customer information. Again, this framework should drive business objectives throughout all layers of the engagement. So that's from engineers all the way down to this, all the way up to the C-suite, or down to the C-suite, wherever their offices are. And make sure that the right people are aware of what is happening and why it's important. The framework also, needs to have a clear communication structure for all of those involved. And it's so that's part of this top to bottom transparency and traceability for the decision process. And realistically, it shouldn't be limited, by specific technologies. It shouldn't necessarily be, hamstrung by whatever the project is. So again, this should be something that's simple and repeatable, and allows things to evolve as time goes on. And the thing about like the number one part you have to have sponsors for every area that's involved. And this has been true for NSX since its inception, really. And NSX is a unique product that tends to have a foothold in many, many different disciplines. I think realistically, the only IT discipline that might not have to have a huge say, but they do need to be involved, is the storage team, because there's not a huge amount of storage requirements as it relates to NSX, but it is there. But in general, when you're doing NSX design and deployment, you've got to have input from compute teams from the vSphere side, for the hypervisor side. You've got to have input from network teams. You got to have input from security teams. You've got to have input from the security policy people. So there's a lot of times there's network security, and then there's the security teams. So there's multiple different silos of things that come across here. So it really is something that tends to touch every single IT discipline. And that's where, as you're building out this framework to do a proper design, we got to have the right people on board from the very outset, because otherwise you could get 6 months into a project, working, even just the project of designing a thing, and be missing some key components, especially if you're connecting this out to, say, public clouds. If you've got a whole other separate team that all they deal with is public clouds, and you never involve them at the outset, well, now you've got a whole other bag of considerations to deal with. So identifying stakeholders is probably if this was the framework of a house, this is probably one of the main pieces of the foundation of that house. And then realistically, we need to have reasons that businesses are doing a lot of this stuff. So this, the engineers typically don't have to come up with a lot of these kinds of explanations on things, but a lot of times that's further up the chain within organizations. But you've got to have these business drivers identified to say what are the things that you're after, especially as it comes to an NSX and turning on certain features over another. Do you need virtualized networking components, so you have to do the overlay networking pieces, or can you just get by with doing security only with VLAN back networks? And what are the things that require that? Are there PCI networks or HIPAA information for private healthcare information? What needs to be understood, and what's the real thing that's making you do a design or do an adoption of some technology? So, and again, the framework has to be flexible enough to deliver products that aren't even haven't been considered as part of the design. So again, if your design initially does not call for overlay networks within NSX, but later on you find out, well, we need to do some workload migration with HCX, and the network extend, we need to do network extension. Well, then you're going to need to modify the design requirements within your organization, because now you have a business need to do workload migration, with another piece of the NSX design framework, or NSX design, or NSX products suite using HCX, and overlay networks. At least there's a minimal configuration of that is required for that. So again, the business drivers, it's this cyclical thing of one thing feeds to the next, and you're going to have to work through all of this process as you go through designing these pieces out. Okay. Part of the design framework is what kind of started to rank through these couple of key areas here. So the use of a standard framework communicates this organized and professional approach as you're working through this. And then we use these things called design qualifiers to ensure that all levels of the engagement are met. Each qualifier affects the other qualifiers, and the qualifiers include, the availability, the manageability, the performance, the recoverability, the security, and the cost. I'm not going to try to pronounce this as a word because it's not a word. But
I've heard it, but with G. I'm not kidding. I've seen it ampers before.
Yeah.
but people don't usually include C in the acronym.
Ampersk or something like that. But yeah. But realistically, this is a thing of, where we need to think about stuff. So let's just say for the cost aspect of it, so what might be in most organizations a very high bar on the cost part of it is, what is the budget for this design or for this project, versus, how much it came in at in the proposal part of it. And can the proposed goals and business requirements, allow the budget to be met. So these kinds of pieces are going to be considered and ultimately against, the same thing on the security side. So, does the budget being up here meet a security requirement that's down here? How important are each of these areas? And we have to kind of go through this qualitative method to get a quantitative result to sort of prioritize how we're going to attack the design framework build out. And again, this is just the pieces of this design framework that really just build the structure of what you're trying to embark upon in designing an NSX-T deployment.
Don't all customers just rate all of those as high?
Probably, but but then you've got other problems.
Probably.
All right. All right. I'm droning on way too long, so I'm going to keep on moving here. All right. So frameworks also have a life cycle. So the life cycle, this is another thing that this is the Deming model, which is a quite popular online model of how to do things or work through solutions and discover problems. So, the way that we sort of put this into is, you plan or discover, you develop, and then you execute and review. So we sort of work through this same type of, cyclical process as part of the life cycle of this design process. So it's just, the discover steps, we define the scope and to educate, the customer and ultimately the team that's working on these things. We document objectives, we test customer objectives against actual needs, solicit and document requirements, assumptions and constraints, and then, continue to work through the process and, we have execute and build, deploy and implement and operationalize, test and verify. It's just, one thing feeds to the next. And this is kind of how you, ultimately test the framework to make sure that it's meeting what you're needing to do. Okay. So as we're working through this, here's sort of the things that as you're looking at, this particular exam, this is the stuff that you're going to see a lot of. And these are the things that you need to kind of work through your head in terms of processing how to think through these things. And what you end up with when you come out of taking this exam is now any meeting you're in from here on out, you hear somebody say something and you think to yourself, that's a constraint. Or you'll be sitting in a meeting and somebody will be talking and you're just be like, oh yeah, that's a risk. And you just can't help but start to like categorize people's statements as they say things after you go through this process. So enjoy that. So a constraint is, these list of things. So yeah, political factors, and that's, business political factors, not necessarily governmental political factors, but if you're working in the Fed space, you might have governmental political factors. Regulatory issues, big one is training and skills that are required. That is probably the number one or two thing in the design process that needs to be considered for teams that are deploying new technology, especially NSX-T, is training. And we can't really harp on that enough. That's a big reason why vBrownBag exists. It's a big reason why I have done this series now for a second year in a row. Is because the training and skills gap within IT is always something that is there and may never fully be bridged, but it is what it is. and probably the last big constraint thing is security requirements. That's sort of a never-ending piece as well. As we always got to consider security. So requirements, again, this is an example of this. The organization has to deal with SOX compliance, or the underlying infrastructure has to have 5 nines or 4 nines or a certain number of nines. Those are static requirements that have to be met, understood throughout the whole process. Assumptions are design components that are assumed to be valid without proof. So that statement in and of itself is an assumption. It is this piece of you can sometimes read through or hear something and you're kind of starting to debate with yourself, is that actually a risk or is that an assumption? So you can kind of look at a scenario and sort of freak yourself out a little bit. But this is why I say in certain scenarios, in real life anyways, there may not necessarily be a wrong answer. Something could potentially be an assumption and a risk at the same time, and still have components of it that are constraint. And so you have to kind of really break down these things as you're working through them. And this is where it gets really challenging in the exam for this particular test, is you have to read through these processes a few times to make sure that you're identifying them the way that the test wants you to. But in general, this is where you're going to spend a lot of your time, your study time is understanding how to break down scenarios into these categories. And we'll do this in a moment. And the kind of the last piece of this is so risks, as a definition here, risks might prevent you from achieving project goals. To identify and list design risks is key. For an example, if you've got the main data center contains only a single core router, which is a single point of failure, that's a risk. Or you could also call out that the team doesn't have the training requirements met for the new NSX-T deployment. They've only got NSX for vSphere training. That's a risk. So lots of these types of things are part of how we talk through this. All right, moving on to design phases. So in the conceptual phase here, we gather the information to create the conceptual design from key stakeholders and subject matter experts. And then, from that comes out the scope, the goals, and the requirements, assumptions, and constraints. And part of that process, probably one of the more critical parts of that process is this thing called the current state analysis. So basically, it's looking at how things are right now, so that you can understand where you're going from in the future. It's that baseline for the deployment of something. And if you're doing, this is where if you're doing things in a greenfield environment where you're just starting fresh, it's always the best place to start from. But that's not always the case in most scenarios. So you've got a lot of things to consider as you're rolling from that. Conceptual design focuses on achieving the organization's business goals and requirements. And you have to determine entities that are affected by this project. Lines of business, users, processes, all that good stuff. You have to determine the goals, requirements, and constraints, how they map to each entity. Design infrastructure that will be necessary to achieve the entity's goals and requirements, while at the same time staying within the constraints. And then we've got to document, the conceptual design with diagrams, tables, text, all the good things that go into documentation that most engineers don't enjoy doing. The conceptual design also categorizes assessment findings, again, into, requirements and constraints. And something, again, this keeps coming up over and over and over again because, ultimately, these requirements need to be provided so that the solution can achieve them. So it's this circular thing of one feeds the next. The constraints are conditions that provide boundaries to the design. The assumptions list the conditions that are believed to be true but not confirmed. And then, by the time you get to the deployment stage, though, all the assumptions need to be fully validated and no longer assumptions. So that's the list you're going to destroy as you get through it. So, eventually the assumptions need to be checklisted off. The risk factors, of course, is anything that might have a negative effect on the design. So logical design includes relationships between major infrastructure components with considerations on the conceptual design, the technical requirements, constraints, and risks. So here's where we start to see this, where the logical design phase calls back to the conceptual phase, because without one, you don't have the other. And that's a common kind of theme that you'll look at as you start to study through this stuff. The logical design is useful for understanding and evaluating the design of the infrastructure when it comes down to the physical side of things. The logical design does not include physical details such as the vendor model, host name, IP addresses, or port connections. It doesn't go down to that level, but it does feed into what ultimately helps build the physical design phase. So the logical design also includes decisions on how to arrange, major infrastructure components to satisfy dependencies and requirements that are specified in the conceptual design. So, for example, design decisions on, management clusters or workload domain clusters, storage appliances, networking, where the workloads are, how the workloads are split out between the clusters, all of those sorts of things can feed towards the logical design. And again, the design phase is an iterative process that continually changes. So here, so the physical design piece of it. So we use, the logical design to get, the part of the get at the conceptual design, but at the same time, we use the logical design to create the physical design. So a physical design includes, specific vendor and implementation details. So this is where your vendor models, host names, IP addresses, all that sort of stuff comes into play in the physical design, because this is where you need to get really specific about how you're laying out hardware, how you're laying out networks, routes, static routes, BGP, whatever you're doing. And the physical design provides, the detailed specifications for purchasing hardware and ultimately deploying the solution. Let's see, this is kind of a repeat thing, but let me just skip through this a little bit here. So again, justifications, this is, pretty similar to the Ampersk thought process, where, designs, there are a series of compromises. When a design decision is not directly related to a requirement, you use the non-functional requirements to evaluate and justify the design. And these are some questions that, you can pause this later and kind of go through if you're looking at kind of more information on, where to go through. And again, probably one of the more important things is it in the budget? Because if you don't have it in the budget, ultimately it's not going to get done anyways. All right. So we use the logical design to create the physical design. The physical design contains that specific vendor implementation details. The physical design provides the information to get to the implementation guide, which is intended to define the steps and variables required to deploy the solution. So in this case, it's focused on the physical design. The physical design moves into implementation details. Again, based on the logical design, more than one physical design can be built based on a quality logical design. So, this is again the idea of this should be a simple and repeatable, iterative process as you work through these things and step through them. They all start to work together as you get further into this design methodology. So at the end of it is you're going to come out with, a set of design documents, and, the number and type of the documents are going to vary by project. There's lots of different factors that are going to dictate those, how, the number and type of those documents. Solution-oriented designs will typically require, a lot more custom documentation. Product-oriented designs tend to include a larger proportion of references to instructions and online documentation, things of that nature. Ultimately, the design document, is a blueprint for the actual design. It includes conceptual, logical, and physical design information, images, especially if you've done this in a whiteboard, you want to capture those things and, make them permanent, pictures that are pretty. Lots of Visio things come to mind. And ultimately, it helps to discuss, all these design aspects as stated by the organization's goals. So as we kind of looked at before, this plan, do, check, act thought process, this is, again, sort of the design deploy process of how we work through these requirements. So we're going to assess things, which we then goes down to designing, deploy, and validate. And then that works back up the chain to ultimately, feed the requirements. And in the same vein, these pieces are also going to come back the other direction to feed the requirements. Everything comes back to, what are the requirements and what are the business goals and objectives and pieces that make up what is required from why the design is the way it is. The requirements are king, really. And then one of the last pieces is the deployment validation, and the installation and configuration documentation that the validation plan and provides with test results. Your requirements vary on this thing, but based on cost and length of the project, the validation is something that we probably don't want to skip that piece of it, because that's where we understand that that if we got everything we needed in the planning process is getting through this, that's where you find your gaps as well. Okay. Last two things before we jump into kind of some discussion here. So a solid design is based on guiding principles, which define best practices, recommendations, and standards. A sound design includes, a design methodology. Again, training is super important, and as well as involving the right stakeholders and having consistent discussions with them. Again, if you're after this VCAP-NV design exam, you can really not spend enough time on understanding the requirements, constraints, assumptions, and risks category. You got to just get through how to break down scenarios and break down information into those categories and buckets, because that is just crucial for understanding the exam, as is even noted in the blueprint. And then, decisions have to be made to balance these technical best practices, business goals, and constraints. Again, it's a back and forth compromising process to go through to get to a good design. And a good design, again, is repeatable, documented with decision rationale, and detailed for clarity. That's probably not stated enough either. Being, I've heard it said to be unclear is to be unkind. And especially if you're giving this thing to somebody else to deploy, if it's not clear what you're asking them to do, then it's just not nice. So be nice to your engineer who's deploying this thing and be clear about what you want. And having a good physical design as part of this too, ultimately feeds what will support the rest of this from the outset. All right. Ken, are you ready?
I was born ready.
Okay. So this is how I'm going to wrap this up today, is look at some uncategorized constraints, risks, and assumptions. Can you read these okay? Or do I need to zoom in more?
I can read them okay. Yeah. I'm going to treat this like a lightning round. I'm just going to try to rapid fire answer them. So probably get a lot wrong.
Yeah, maybe not. I don't know. Okay. So compute nodes are HPDL 388G11s, rack mount servers. Physical specifications of the servers included in the BOM to be used are and not to be changed. What is that? Is that
so that's absolutely a constraint. Could be a risk depending on the BOM. It might not be suitable, but I'm gonna say constraint.
All right. I'm going to right, this is going to take forever if I actually do this. Okay. Dynamic routing is not allowed per the NSX to peer NSX virtual networks with a physical network. What is that?
Borderline risk, in my opinion. I think it would not be a very good architecture. Probably make it work, but I'm going to call it risk.
Just going to note it right next to it here. All right.
Okay.
All hosts are installed, powered on, and updated to the latest firmware in both sites before deploying and allowing parallel implementation in both sites.
That's an assumption.
Okay. The deployment can run at the same time for both sites.
I'm also going to say assumption.
High physical network over subscription ratio between leaf switches and spine switches. It's 10-1.
Say risk.
Some of these I thought could also be a constraint, but yeah, I mean that could be a risk, but at the same time, if they have like low budget,
it's
on
okay
the network
to
side,
whip out your buzzer.
you know.
And no,
I don't. I'm just saying, like this is where you kind of start when you start to roll through these scenarios. You can start to see there's a little bit of gray area in some of them sometimes.
Right? Yeah.
You know. So prerequisites workbook will be ready before deployment.
That's a big time assumption.
Yeah, that's
never worked with a customer.
That's an easy one. Current network infrastructure and bandwidth will be sufficient for all types of traffic.
Also an assumption.
But technically could also be a risk.
Or just a requirement.
Yeah, I would over that, yeah.
Is requirement one of the things we can fill in here?
No, it should be, but it's not on this. I think it's on another tab.
Okay.
Well, this is the requirements. So we're gathering the requirements as part of this. So each of these things feeds the requirements. Top of rack switches are Cisco, blah, blah, blah. 4 top of rack switches are available at site Y and 2 at site Z.
I would call that a constraint. It's probably something you can work well within, but need to know those details, right?
The third witness site has a single ESXi host, which is, oh, did I?
Yeah.
Oh, yep. The Z site has a single rack to host an entire compute node.
That's a constraint, in my opinion.
And like I said, for today, there is no wrong answer. Third witness site has a single ESXi host, which is a single point of failure.
I would call that a risk.
I'd 100% agree. The entire infrastructure is hosted on a single logical site.
I don't know. Do you think that's a constraint or a risk, Britton?
I think it's more of a constraint.
Okay.
I mean, you could technically say it's a risk too, but that's one of those things where it depends.
Right.
Because this is only I don't know. There's more information is required on most of these things, but this is the kind of stuff you run across. Number of available racks at each site, 1 rack in TXX, 2 in RVA.
Constraints. Got to design for what you got.
We'll do a couple more and then we can be done.
Okay.
Third site will be ready to host witness appliances. At a minimum, an ESXi host is required. Other CPU, memory storage, network requirements will be shared in a prerequisite workbook. Oh, so there's other book of information that's hiding somewhere you have to find.
Oh boy, assumption. We're stating this is going to be available, but we don't know for sure.
Yep. All right. Last one. Current average network round trip time latency between both sites is around 1 to 2 milliseconds, and the maximum is under 5 milliseconds.
I guess assumption.
Yeah, that's some pretty specific information there. So
we expect this to be the reality.
Yeah. So that right there is a lot of the type of stuff that you need to run through for this exam. It's just looking at these types of scenarios. And this is, if you work in IT, you don't have to go far to find these types of scenarios and be able to break them down. You probably run into this every day, sometimes multiple times a day, where somebody brings up something. And like I said, as you kind of get into this, you'll start to see these questions and things pop up in your everyday work day, and you'll just start categorizing them as they pop up. So,
Britton, did I?
Yes, sir.
I know there's no right answer, but do you think I'm ready for a VCAP?
I think you're ready to start studying.
Okay, fair enough.
How's that for a political answer?
I know, right? It just implies that no, I'm not.
Well, yeah, I took the full exam, or took the full class, and really with no study time, just went and took the exam and tried it and failed on my first attempt. So sometimes you have to fall on your face, try again, and realize you actually do need to study. So
go figure.
Right. So that's it for today. I hope that was useful and informative. I mean, if it felt repetitive in there at all, which I felt like it was a little bit repetitive, that's probably by design, because most of this stuff, like I said, throughout the whole thing, there's this cyclical repeat-driven methodology that works its way throughout this whole process, and that comes up in the exam a lot as well. So, but the biggest takeaway that I can give anybody through this is just, yes, make sure that you are understanding the requirements, constraints, assumptions, and risks, and how to categorize things for those 4 areas, because that is absolutely key in this process. So
awesome stuff, Britton. Thanks so much. This was great. Thank you for doing this series.
Yep.
Folks, be sure to tune in 2 weeks from today, August 25th, 2021, if it's not past that date already, and join us for the thrilling conclusion of this NSX-T update series from Britton Johnson. Thanks again, Britton.
Yeah, thank you, Ken.
All right, so long.